Let us first discuss about angle of friction. We can just write down about angle of friction that when a body is at the verge of sliding, the angle between the normal reaction and total contact force is termed as angle of friction. As we know very well that friction as well as normal reactions, these are horizontal and vertical components of the net contact force acting on a body. So if there is a body which is experiencing a normal reaction in upward direction, if we exert an external force onto it, ground will also exert friction on it. The resultant of this normal reaction and friction is R, which we term as total contact force. Now, as you increase the external force, the friction will increase and the body will start a sliding, or it will be at the verge of a sliding when friction reaches the value of, it will approaches the value of mu n. Now, when friction will approach the value of mu n, we can directly state in this situation the angle between the total contact force and the normal reaction is denoted by lambda, and this lambda is called angle of friction. Now, as this friction, this is normal reaction. Here 10 lambda we can write as F upon n. At the verge of a sliding, it is mu n by n. N gets cancelled out. 10 lambda can be written as mu, or lambda is 10 inverse of mu. This lambda we term angle of friction. So always keep in mind, angle of friction can be written as 10 inverse of the coefficient of friction between body and the contact surface between which a sliding is just going to be started. Now we'll study angle of repose. For angle of repose, we consider a body which is placed on an inclined plane. So if a body of mass m is placed on inclined plane, say if its inclination angle is theta and its friction coefficient is mu, we know well that in downward direction it will experience mg. Along normal to incline and parallel to incline, the force components are mg cos theta and mg sin theta respectively. Here the normal reaction will be balanced by this mg cos theta, and as body is only allowed to slide along the plane, we can write that for equilibrium along perpendicular to the inclined surface, we can write n is equals to mg cos theta. In this situation, mg sin theta will have a tendency to slide the block down, but friction will act in upward direction, which will not allow the block to slide unless it will exceed the limiting friction. Now, if we start increasing the value of this inclination angle theta, we can say this mg sin theta will increase and the value of friction will also increase. We can say if m is at rest, this implies friction is equals to mg sin theta. As theta will be increasing, friction will also increase. As soon as friction approaches its limiting value, where limiting value of friction is mu n and n is mg cos theta, it will be mu mg cos theta. As soon as this mg sin theta approaches the value of mu mg cos theta, the block will start sliding. So we can say block will start sliding down at an angle of inclination theta is equals to theta r when mg sin theta r becomes equals to mu mg cos theta r. Here mg gets cancelled out and we can write tan theta r is equals to mu, or theta r can be written as tan inverse of mu. This angle at which the body just starts sliding we call angle of repose. You can see the numerical value of angle of repose is equal to angle of friction. However, it is defined in a different way. We can say angle of repose is that angle of inclination at which a body starts sliding under the effect of gravity. And in case of angle of friction, it is defined as the angle between the total contact force and the normal reaction acting on the body. So be careful about these two definitions.